Princeton. Break time equals 500 men's 1,957. A physicist carries a stack of equations. He believes he has solved the greatest problem in physics. 2 years later, the establishment laps him out of physics. The quantum leap. But a quantum computer proved he was right. At the quantum leap, we trace what science built. Hugh Everett III, his theory, the universe branches. Every quantum event splits reality, every possible outcome happens. Not metaphor, not philosophy. A mathematical prediction, peer-reviewed. Another version of you is reading this now. The question isn't whether this sounds strange, it does. The question is, what does the evidence actually show? We traced every major physics experiment from 1957 to today. The results converge in a direction nobody wants to admit. 3 Nobel Prize winners, 16 key experiments, 1 stubborn answer. But first, what exactly was Everett trying to solve? The measurement problem had paralyzed quantum physics for 30 years. A quantum particle exists in superposition, every state simultaneously. But when measured, it instantly collapses to one outcome. What causes the collapse? The Copenhagen interpretation observation. Observed by whom? The photon doesn't care. What happened before the first observer existed? Copenhagen gets uncomfortable very quickly. Bohr never fully resolved it. Everett's answer: nothing collapses. Everything happens simultaneously. Every quantum outcome becomes a real branch. The wave function never collapses. It keeps evolving, always. We see one branch, we are entangled with it. Other branches are equally real, simply inaccessible. Everett's formulation requires no additional new physics. Copenhagen adds a special rule for observation. Everett removes it. Occam's razor should favor the simpler explanation, but physicists rebelled. Bohr visited Princeton. The meeting was brief. Everett was devastated. John Wheeler had also gone cold. Everett was alone. He left academia for the Pentagon, defense contracts, classified work. He drank heavily. His health deteriorated. He died at 51. His daughter Liz died. Her note: she'd find his universe. Mark Everett leads band Eels, found father through physics. In 1970, Bryce DeWitt rediscovered Everett's papers. He published them. A generation encountered them fresh. And then in 1985, David Deutsch changed everything. Deutsch: if many worlds is true, it has a testable consequence. Quantum computers could only work if other branches exist. A quantum algorithm factors large numbers faster than classically possible. Classical computers must try every factor sequentially. Quantum ones don't. Deutsch asked, where is the extra computational power coming from? One single universe cannot hold this computation load. His answer: the computation is distributed across parallel branches. Every quantum algorithm you run touches other universes. This isn't philosophy. Deutsch wrote the mathematical proof. We had to check the methodology twice. The proof holds. It has held for 40 years. But quantum computers were theoretical in 1985. We needed hardware. The hardware arrived, and with it the experimental evidence. But before hardware, another crisis. Back to Everett's core problem. If every branch is real, why one experience? Zurich at Los Alamos worked this problem 20 years. His solution: quantum decoherence, entanglement with the environment. When a quantum state touches environment, branches seal. The occurrence happens in 10 to minus 20 seconds, unmeasurably fast. This is why your coffee mug never superposes. Decoherence seals branches off, doesn't eliminate them. Zurich published the full decoherence theory in 2003. By 2003, a new consensus was forming. Skeptics remained. Max Tegmark surveyed quantum physicists in 2014. More than half many worlds is most likely or plausible. The theory Bohr dismissed became the majority position. Majority is not proof, we needed experimental evidence. Bell's inequality test is the most decisive quantum experiment. Bell proved hidden variables limit correlation values. Aspect measured correlation shattering Bell's limit. Every time. Hidden variables eliminated. Universe is genuinely non-local. 2022, the Nobel Committee in Stockholm made it official. Aspect Clauser Zeilinger. Bell violations confirmed definitively. What almost no press reported, what this rules out. Hidden variables gone. Copenhagen collapse still possible. Copenhagen requires a special collapse. Collapse isn't observed. Many worlds requires no collapse. The wave function continues. As of 2022, the simplest answer is Everett's 1957 proposal. We haven't reached the most powerful evidence yet. For that, we go to California, a chip called Willow. In 2025, Google announced their Willow chip results. Willow demonstrated quantum error correction at scale, a first. Error correction is the hardest quantum computing problem. Quantum states collapse when disturbed. Errors accumulate. Classical computers copy bits. You cannot copy quantum states. Encode one logical qubit across many physical qubits. Willow crossed the threshold. Adding qubits reduces errors. David Deutsch read the Willow results. He had one interpretation. To correct one qubit, Willow tracks coherence across many states. Deutsch calls these shadow qubits in parallel branches. Error correction only makes sense with information in other branches. Not metaphor. Deutsch wrote the formal proof in 1985. Willow's 2025 results match that 40-year-old prediction. Over half of quantum physicists believe many worlds. 2014 survey. That number has grown since Willow. The field is shifting. Let's be clear about what this is and isn't. Willow is strong circumstantial evidence, not proof. Sean Carroll at Johns Hopkins is direct on this distinction. Carroll published predictions what MWI says Copenhagen cannot. Specifically, decoherence measurements should differ between interpretations. Early 2026 NIST experiments show Carroll's predicted pattern, not peer-reviewed. We flag this as preprint. The scientific community is still evaluating. Trajectory is clear. What does a branching universe look like from inside? It's 2038. You sit in a hospital waiting room. A quantum encrypted message arrives. Safe. Unbreakable physics. That encryption depends on the physics we've been tracing. In that moment, you are a node in branching reality. Is Everett's framework the most convenient story or true? Here's where physics becomes a civilizational question. The scenario forked two different 2040 futures from one question. In one version, quantum computing scales with Deutsch's framework. Drug discovery accelerated. Climate models become exact. In the other version, quantum computers are black boxes, efficient but slower. 2025-2030 determines which path. The regulatory vote is mundane, the stakes are enormous. Everett died in 1982 before quantum computers existed. He proposed a framework quantum computing eventually required. Dr. Goodenough published his breakthrough at 57, Nobel at 97. Everett didn't see vindication. The science didn't need his witness. Now the direct question, should we believe many worlds? Honest physics answer, belief is not the right frame. Which interpretation is simpler, testable, and consistent? On simplicity, Everett wins. No collapse postulate required. Carroll's 2023 framework offers the first experimental discriminator. On consistency, no known experiment has contradicted MWI. But there is a limitation every physicist must acknowledge. We have never directly observed a branching event. Decoherence seals branches faster than any measurement can follow. Maybe inherent or future physics resolves it. The Hawking-Hurtad 2018 paper proposed a CMB signature approach. Hawking submitted it before he died. JWST is now checking. The 2023 JWST data shows cosmological anomalies. Preliminary. We are being honest, no conclusion can be drawn yet. The trajectory is consistent with a multiverse signature. The physicists who watched Contact in 1997 are building JWST. What they find is stranger than any science fiction. Back to Hugh Everett. What he understood that others missed. The measurement problem dissolves entirely in MWI. You entangle with the particle, observer and observed branch. No special role for consciousness in Everett's theory. Any physical system can cause decoherence, not just humans. This is deeply counterintuitive to a culture raised on Bohr, perhaps why it took 68 years to approach acceptance. So where does this leave us? What to carry away? First, parallel universes are not fringe. They are mainstream physics. Second, every quantum computer you use touches this question. Third, the evidence trajectory points one direction, slowly. We live in the years this question is being answered. Everett was right. We cannot prove it yet. Gap closing. The full paper trail is linked below. Carroll, Deutsch, Zurich. Next week, the Alcubierre drive. NASA's warp bubble measurements. Star Wars 1977 Dreamers now run those NASA tests. Full breakdown pinned in the comments. Subscribe now.